Hi everyone, I am Dr. Shigar Kanti, Associate Professor of Mathematics, Government First Grade College, KR Puram, Bangalore. In this video, we study session number 29 of third semester BSc Mathematics, Bangalore University, Bangalore City University, and Bangalore North University. In this session, we study the definition of series, definition of partial sums, the nature of the series, and some examples on series. Let us go to the definition of the series. Already we have studied a sequence. Okay, sequence already we have studied, and we have studied the nature of the sequence. Okay, so here let me consider that A and B is sequence of real numbers. Then if I consider their sum A1 plus A2 plus A3 plus up to AN and so on, is called a series of real numbers and is usually denoted by summation sigma an n from 1 to infinity or just simply sigma an. And now, so that is the series is nothing but a1 plus a2 plus a3 plus a4 and so on. Now let me take S1 is equal to A1, that is the first term, and S2 is equal to sum of the first two terms, that is A1 plus A2, and S3 equal to sum of the first three terms, A1 plus A2 plus A3, and Sn is equal to sum of the first n terms, A1 plus A2 plus A3 up to An. And these S1, S2, S3, Sn are called first partial sum, second partial sum, third partial sum, and so on, and nth partial sum. Now, we have got, for a given series, we have got the terms S1, S2, S3, S4, Sn, okay. Now, we make one sequence here, that is, I will denote this sequence by Sn. Sn is equal to S1, comma, S2, comma, S3, comma, and so on. This is the sequence. And this sequence is called the sequence of partial sums of the given series sigma an. Okay. And we call this as the associated sequence. That sequence of partial sums, we call this as the associated sequence. That is here for every series, there is an associated sequence. Now we define the convergence, divergence and oscillation of the series. See here, if sigma an is a series, correspondingly there is a sequence, that is sequence of the partial sums. We know the definition of the convergence, divergence and oscillation of the sequence. Now, we define the nature of this series depending on the nature of the corresponding sequence. If the sequence Sn is convergent, then we say that the given series is convergent. If the sequence Sn is divergent, then we say that the given series is divergent. If the sequence Sn is oscillatory, then we say that the given series is oscillatory. Okay, this is how we define the convergence, divergence and oscillation of the series. Okay, let us go for an example. Discuss the convergence of 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 plus up to 1 by n into n plus 1 plus and so on. Here the nth partial sum is Sn is equal to 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 and the nth term is 1 by n into n plus 1. I can write this 1 by 1 into 2, that is 1 by 2 as 1 by 1 minus 1 by 2 plus this can be written as 1 by 2 into 3 can be written as 1 by 2 minus 1 by 3 plus 1 by 3 into 4 can be written as 1 by 3 minus 1 by 4 and so on. 1 by n into n plus 1 can be written as 1 by n minus 1 by n plus 1. See here 1 by 1 remains as it is, minus 1 by 2 plus 1 by 2 gets cancelled, minus 1 by 3 plus 1 by 3 gets cancelled, minus 1 by 4 plus 1 by 4 gets cancelled, minus 1 by n plus 1 by n gets cancelled. Then what remains is 1 minus 1 by n plus 1. This is our Sn. Okay, this is our Sn. Now if I take limit onto this Sn, limit of Sn as n tends to infinity equal to limit n tends to infinity 1 minus 1 by n plus 1. As n tends to infinity, this term tends to 0. 1 by infinity equal to 0. That is 1 minus 0. This is equal to 1. This limit is finite and unique. Therefore, the sequence Sn is convergent and therefore the given series is convergent. Okay. Next I will go to another example. Discuss the convergence of 1 square plus 2 square plus 3 square n square and so on. So here this is our sigma an, and here nth partial sum is equal to sum of the first n terms, that is 1 square plus 2 square plus 3 square plus up to n square. And we have a formula for this. Sum of the squares of the first n natural numbers is given by n into n plus 1 into 2n plus 1 divided by 6. This is our Sn. Now if I take limit onto this one, limit of Sn as n tends to infinity is equal to limit n into n plus 1 into 2n plus 1 divided by 6. If I put n equal to n tends to infinity, numerator becomes infinite. Infinite by any finite quantities, again infinite. So I am getting limit of Sn is equal to infinity. Therefore, this sequence Sn is divergent. If this sequence Sn is divergent, then we say that the corresponding series is also divergent. Okay. Next example, I will go for discuss the convergence of summation minus 1 to the power of n. So that is sigma n equal to, put n equal to 1, 2, 3, 4, 5, 6 like this. First term becomes n equal to 1 minus 1 to the power of 1 is minus 1. N equal to 2 minus 1 square is plus 1. N equal to 3 minus 1 cube is minus 1. N equal to 4 minus 1 to the power of 4 is equal to plus 1. That is I am getting minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 like this. Now here, what is S1 here? S1 equal to minus 1. What is S2? S2 equal to 0. What is S3? S3 equal to sum of the first three terms. This is equal to minus 1. S4, this becomes 0. S5 minus 1. So that means here, if n is odd, then I am getting Sn is equal to minus 1. And if n is even, I am getting Sn is equal to 0. If I take limit onto this one, limit of Sn as n tends to infinity, this is equal to either 0 or minus 1. This is depending on n. So that means here, the limits are finite, but the limits are not unique. Limit is not unique here. So that means here, Sn is oscillatory. That is, this sequence is oscillatory. If this sequence is oscillatory, then you say that the given series is also oscillatory, and this oscillates finitely because limits are finite here. Okay, 0 and minus 1, but not unique. Therefore, we say that the sequence oscillates finitely. Therefore, the series oscillates finitely. Next, we go for another example. Discuss the convergence of minus 1 to the power of n into n. That sigma n equal to minus 1 to the power of n into n. This is equal to, so put n equal to 1, I am getting minus 1. N equal to 2, I am getting this. N equal to 2, I am getting this is plus 1. This gives either plus 1 or minus 1. If n is even, this is plus 1. If n is odd, this is minus 1. Okay. So minus 1 plus 2, minus 3 plus 4, minus 5 plus 6. So this is our series. Now if n is even, let me take n is equal to say 2k. Then these terms can be written as, first I will take first two terms here. I will write minus 1 plus 2 in one bracket. Next I will take third term and the fourth term. I will put in one bracket. Fifth term and sixth term I will put in one bracket. And the last two terms I will put in one bracket. See, each bracket is positive here, plus 1 here. Minus 1 plus 2 is 1. Minus 3 plus 4 is 1. Minus 5 plus 6 is 1. Minus of 2k minus 1 plus 2k. This is also equal to 1. Total, how many 1s are there? K times 1s are there. That is S1 equal to 1 plus 1 plus 1 plus up to k times. That is here, Sn is equal to k. So now if I take limit on Sn, limit of Sn as n tends to infinity equal to limit of k as n tends to infinity. K is nothing but n by 2. Now if I put n equal to infinity, that is as n tends to infinity, this tends to infinity. So that means here limit of Sn as n tends to infinity means this sequence is a divergent. That is, if I take n is even, and I can say that this is divergent. Okay. Now what happens if n is odd? If n is odd, that is, let me take n is equal to say 2k plus 1. Then the terms are minus 1 plus 2 minus 3 plus 4 up to minus of 2k plus 1. What I do is I will keep the first term as it is, minus 1 as it is. Then for 2 minus 3, I will write this is minus of minus 2 plus 3. And then 4 minus 5 is there. I will write this is minus of minus 4 plus 5. Similarly, last minus of 2k plus of 2k plus 1. Then this is minus 1 as it is. See, this bracket is 1 and before this negative sign is there, this becomes minus 1. Similarly, this bracket is 1 and this has a sign negative. So this becomes minus 1. Similarly, last bracket also 2k plus 1 minus 2k is there. This also becomes 1 with a negative sign. So that is here minus 1, minus 1, minus 1, minus 1. Up to how many times? Up to k plus 1 times. Here from this to this k times and plus 1 term is there. So that is up to k plus 1 times. Minus 1, minus 1, minus 1 up to k plus 1 times. So this value is equal to minus of k plus 1. Now if I take limit onto Sn, limit of Sn as n tends to infinity is equal to limit n tends to infinity minus of k plus 1. And we have n equal to 2k plus 1. Therefore, k plus 1 can be written as n plus 1 by 2. If I take the limit onto this one, this becomes infinity with a negative sign. That is minus infinity. So that means here, if n is positive, if n is an even number, I am getting its limit is equal to infinity. If n is odd, I am getting its limit is equal to minus infinity. So that is here limit is not in here. Therefore, we say that limit of Sn as n tends to infinity equal to plus or minus infinity. So that means here the sequence Sn is oscillatory. If the sequence Sn is oscillatory, then the given series is also oscillatory. And here oscillates infinitely because they are acting the limit as plus or minus infinity. So that is the given series oscillates infinitely. Okay. With this I will stop this session. Thank you.